Yeah, very good morning. The next topic, that is laser diode. Today now I am going to discuss about laser diode. Okay. What is laser diode? Now I have completed in previous session. Now I am going to, and I already completed what is this laser and what is next one is LED. What is LED and what are the configurations in LED? I already completed in last session. Okay. Today, now I am going to discuss about laser diodes. What is laser diode? Here we know that what is before laser diode. Laser is, that is light amplification stimulated emission, emission of radiation. A laser diode is, that is electronic device which is converting given electrical signal into a device. A laser diode is a device that is converting given any electrical signal into the light source. That is nothing but a laser diode. Here laser diode is, we are getting a high intensity coherent light output. We are getting a high intensity coherent beam output. Laser diode is very small in size and up and it appearance also, it's very small. Okay. And it is similar to the transistor and has a operation of LED. Whatever that operation in LED we are using, that is the same operation we are using. Same operation is in laser diode also. The materials, whatever the material which is used to fabricate the laser diode are gallium arsenide. The material we are using, that is the gallium arsenide. It is also called the injection laser diode. Okay na? It is working on the principle of, that is the PN junction diode forward bias condition only. Next, this symbol of laser diode. This is symbol of, that is a laser anode is there, cathode is there. Okay. Now, laser diode construction. How we are constructing a laser diode? Laser diode construction. Here we are using for the construction of the laser diode a two, that is the PN junction diode. Two, we are using the material, whatever the gallium arsenide we are using for the construction of the P-type semiconductor. In say N-type semiconductor, we are using the same material, that is the gallium arsenide we are using. Okay. Now, when we are forming the P-type semiconductor and N-type semiconductor, we can join together, we can form one layer, that is the deflection layer. Okay, na? That is that we can form that PN junction, that is known as that PN junction, the deflection layer. In this P-type we are having electrons, and N-type we are having holes. When we are connecting P-type, N-type, the electrons are moves one direction and the holes are moves one direction, and we can form that when it is moves the one direction to another direction, we can generate it one electrical energy. Okay, electrical signal. The P-type of that semiconductor device we are connecting to positive terminal of the battery, and the N-type of the semiconductor we are connecting to a negative terminal of the battery. Okay. Here the laser diode is made up of a doped. What is that? Actually, that is a laser diode that is doped with gallium arsenide. One doped with gallium arsenide layer, which is produced the N-type semiconductor, and one more type, whereas another is doped with the gallium arsenide, that is the same material, will produce that P-type semiconductor. In laser diodes, in this laser diodes, selenium, aluminum and silicon are used as doping agents. For the doping of the electrons of the holes, we are using these are the materials. It acts as the operation of this laser diode is also in the working of the PN junction diode forward bias condition. When a P-type layer is joined with N-type layer, a PN junction is formed. Okay, and the point at which the P-type and the N-type layers are joined is called PN junction. The PN junction separate the P-type and N-type semiconductors. Okay, this is the PN junction. P-type semiconductor material and N-type semiconductor material. And the main steps required for producing the coherent beam of light in laser diodes, whatever that the some main steps, what are the main steps are required for the to produce the coherent beam of laser output, okay na, in laser diodes. There are the three steps are required. The first one is there is absorption of energy and the spontaneous emission and the stimulated emission. Absorption of that first one is, these are the three major steps we are using to produce the laser beam output. Okay na? What is that laser absorption of energy? Absorption of that energy means whenever we are giving that external source, external energy to the particular electron, in that conduction, there are the two layers are there, conduction band and valence band. In that valence band, and in the valence band, that is the lower level energy, where conduction band, that is higher level energy. In middle of that band gap is there, and that band gap we are producing that laser beam output energy. Here in this valence band, whatever the electrons are there, for the excitation of, for the exciting of these electrons, now we are giving some external energy, that these electrons are absorb this external energy, and it will emit the, it will travels the from the lower level to the higher level. That means the absorption is nothing but whenever we are giving that energy, that electrons are absorbing the energy, that is absorption of energy. Okay, and next one, see here, when now I am giving this electrical energy to the valence electron, here this electron, it absorbs this energy, then it will move to the higher level, that is absorption. And next one is spontaneous emission. In the spontaneous emission means what? When the spontaneous emission means is the process of emitting the light or photons, is the process of emitting the light or photons naturally while electrons falling into the lower energy states. Okay, when the electrons are moves from the lower level to the higher level, when then again it falls down to the lower level, it will not stay the up to longer time, it will stay only small time, less amount of less time, then after it will falling down to the lower energy level. Then when it is falling down, then it will emit some energy, that energy is in the form of a photons, the photons, that is h mu, the photon energy is in the form, that is nothing but a electrons, that means is in the nothing but a light. Okay, in laser diode, the valence electrons are in the lower energy state. Okay, therefore the holes generated after the valence electron left are also in the lower energy state. Okay, on the other hand, the conduction band electrons are free electrons are in the higher energy state, in simple words, the free electrons have more energy than holes. Okay, holes, the free electrons, whatever the free electrons are there in the conduction band, need to lose their extra energy in order to recombine with the holes in the valence band. Okay, in the valence band. Then after that, the free electrons in the conduction band will not stay the long time period. After a short period, the free electrons recombine with that lower energy holes by releasing energy in the form of a photons. Photons. Here this is. It will not stay the, when the electrons holes are when absorbing the energy. Here the electrons are moved from the lower energy to the higher energy. Okay na? When it is after moving, here one hole is created. This hole okay na, this hole is created. After electrons are moved to the higher level, then again it is falling down to the lower level. When it is falling down to the lower level within a short period of time, then it will emit some light energy, that is in the form of a photons. That is spontaneous emission. In stimulated emission, what is the process is going on there? In the stimulated emission is also, the stimulated emission is the process by which excited electrons or free electrons are stimulated in falling into the lower energy state by releasing energy in the form of a light. Okay, the stimulated emission is in a artificial process. Artically, this is the artificial process. In stimulated emission, the excited electrons or free electrons need not wait for the completion of their lifetime. Before the completion of their lifetime, the incident or external photons will force the free electrons recombine with that holes. In stimulated process, each incident photon will generate 2 photons. Okay, and all the photons generated due to the stimulated emission will travel in the same direction. As a result, a narrow beam of light, high intensity light were produced. Okay, narrow beam output. This is more than 2 photons are generated, released. Okay, a narrow beam output were generated. Now, coming to the actually operation of laser diode. A laser diode basic operation. Before I am going to that operation working of this laser diode, the construction now I want to show here. This is the construction of laser diode. We are having anode and cathode, p-type semiconductor material and n-type semiconductor material. 2 mirrors are there. First one is the fully reflected mirror. This is partially reflected mirror. Here these are the reflected photons. These are all the reflected photons, and this is depletion region. In this depletion region we are getting some output, that is light emission. Okay, this is the general construction of laser diode. How laser diode is working? In this laser diode working, when the DC voltage is applied to the terminal, applied across the laser diode terminal, the free electrons move across the junction region from the n-type material to the p-type material. Okay, in this process, some electrons will directly interact with the valence electrons and excite them to the higher energy level, whereas some other electrons will remain recombine with the holes in the p-type semiconductor and release the energy in the form of a light. This process of emission is called spontaneous emission. In the spontaneous emission, the photon generated and that photon generated due to the spontaneous emission will travel through the junction region and stimulate the excited electrons. As a result, more photons are released. This process of light of photons emission is called stimulated emission. The light generated due to the stimulated emission will move parallel to the junction. The two ends of the laser diode structures are optically reflective. One is fully reflective, one is partially reflective. Fully reflected end will reflect the light, whereas the partially reflect the end will reflect the most part of the light allows as a small amount of the light. That is narrow beam output. The light generated due to the stimulated emission is escaped through the partially reflected mirror only end of the mirror diode to produce the narrow beam laser. All the photons are generated due to the stimulated emission will travel in the same direction, only one direction only it will travel, and therefore this light will travel to long distance without spreading in the space. This is about laser diode working. And coming to the advantages of laser diodes. Laser diodes are very small size, okay, a simple construction, lightweight and very cheap, small size, heavily reliable compared to that other type of that lasers, and longer operating life also, okay, and highly efficiency, mirrors are not required in the semiconductor lasers, low power consumption. These are all the major advantages of laser diodes. Coming to the next one, disadvantages of laser diodes. They are not suitable for applications of more power, whereas the high power are required in, we are not using this laser diodes. And next one is the semiconductor lasers are highly dependent on temperature. Okay. These are the main two drawbacks. And applications of laser diodes. Where we are using this laser diodes? Laser diodes are used in the pointers, laser printers, laser scanners, optical communications, and what is that? Laser barcode readers purpose we are using this laser diodes. And one more major application of this laser diode, to find the range finding purpose. In industrial application, we are using this laser diode as a range finding purpose. Okay, these are the applications of laser diodes.